Assalamualaikum. My name is Muhammad Zain bin Yaakob. For this nanocoating task, I will explain about enhancement of boiling heat transfer performance using nanocoating. Nanocoating is the sealing of material at the atomic level through methods such as atomic layer deposition or ALD. The term nanocoating refers to the coating itself, like example, nanocoating on the surface of something substrate, or it can refer to the process itself. A nanocoating is a consistent network of molecules which arrange themselves to form nanostructure network that is used to protect the material it is covering. A nanocoating can be produced with utmost precision through a process which involves atomic building blocks where atoms are deposited in controlled fashion to produce a layer that conforms uniformly on very distinct features of the surface. Nanocoating can use in many applications like my topic, which is in boiling. Boiling is a process in which vaporization takes place at solid and liquid interference. When the temperature of heater surface exceeds the saturation temperature of liquid. Boiling phenomena can be classified in two ways, which is first pool boiling and second flow boiling. In pool boiling, phase change occurs from liquid to vapor when a liquid receives heat from the heated surface and converts into the form of vapor with the help of bubble. During a flow boiling, fluid is forced to flow. In flow boiling, all the phases flow simultaneously in a confined channel such as vapor and liquid in a pipe. Flow boiling occurs when convective heat transfer introduced by the help of pump and it has flexibility of orientation. The flow boiling is an effective way for heat transfer mechanism. How nanocoating is used in boiling heat transfer enhancement. For surface coating in pool boiling heat transfer enhancement, almost 10 years before, some research found notable enhancement is critical heat flux during a pool boiling. The working fluid was water and concentration of aluminum oxide nanoparticle below 0.01% by volume was taken into account. The tests were carried out the nanoparticle coated surface to improve boiling heat transfer. One researcher, which is Sislinski, studies several technological parameters of the porous coating that influence the heat transfer rate. Surface will deposited metal particles have a high heat transfer coefficient than a flat surface with the same heat flow. This table shows a summary of pool boiling heat transfer performance with coated surface. From this table, we can see many research was done to study the effect using nanocoating in boiling process. Like example, Chang and Yu used diamond as a coating material and used copper as a basic coating. Next, Hendrik used zinc oxide as coating material and copper and aluminium as a base coating. From this table, we also can see many material coating like aluminium, copper, ammonia and so on. One of the researchers, which is Lee, found that heat transfer coefficient depends upon the layer of coating material. It is found that 20B layer of PET MWCT coating show the best heat transfer performance as compared to 40B layers which show the lowest heat transfer performance. It has been concluded from the experiment that there are the optimized number of layers one can get the enhancement in the heat transfer performance. Next, I will explain about surface coating for flow boiling heat transfer enhancement. Okay, from this table, we can see some examples like Kanikar perform experiment on flow boiling phenomena using coating on CNT on surface of copper microchannel. They use water as working fluid. They found enhancement of critical heat flux and boiling heat transfer coefficient. They developed monolithic micro or nanofabrication process to produce a silicon nanowire coated microchannel. They conduct flow boiling heat transfer experiment for performance comparison of coated and uncoated surface of microchannel. Next, Davidowitz and Zelensky conduct experiment for determination the application of porous coating in flow boiling phenomena using pure and mixed refrigerants as a working fluid. They found highest average heat transfer coefficient and low pressure drop for porous coated surface as compared with smooth tube with the same mass flow velocity. They also proposed a correlation for calculation of average heat transfer coefficient in a flow boiling with porous coated surface. Last but not least, for a conclusion, it has been found that nanoparticles after use deposited on the heated surface and trade as a coated surface. But higher the deposition will lead to falling phenomena which decrease the heat transfer coefficient and critical heat flux. That's all from me. Thank you for listening.